We are the AI course advisor team. We're going to go through some quick intros before we dive into the details of our project and show you guys a quick demo. So my name is Jack. I'm a rising sophomore here at Duke.
I'm Alora. I'm a rising junior at Davidson College.
My name is Adam. I'm a rising junior at NC State.
My name is Hui. I'm a rising senior at Davidson.
And my name is Esther, and I'm a rising junior here at Duke.
And I'll send it over to Adam to tell you more about our team.
Thank you, Jack. So as you guys just heard, we're from different universities across North Carolina. The reason for that is because we're part of the NC Share grant. This grant aims to spread educational resources across North Carolina, and particularly for us, at least, Code Plus was the resource that got spread. And so as you can see on screen as well, these are our stakeholders. We have John Reifschneider, who's a professor in AI or in engineering that specializes in AI. And we also have the Office of Academic Advising, the Office of the Provost, and OIT. And I'll pass it off to Alora to talk a little bit about our project.
Yeah, so as Adam mentioned, one of our main stakeholders is John Reifschneider. And in his lab, he has a graduate student named Daniel who actually built a smaller version of what we were then tasked to do this summer. So we were given that existing Git repo, and we were asked to build on that to build a 24/7 AI course advisor made to help students alleviate the pressures and issues of course registration and course selection. A main goal of that was not to replace the current advisor system, instead work closely with it to integrate what we would then build into what Duke has already to help both advisors and students. So now that you have an idea of what our main goal was this summer, I'm gonna send it over to Jack to talk about some of the ideas that we were integrating during our project.
So retrieval augmented generation, or RAG, is a really important idea in our project. And essentially what RAG is a process that allows us to utilize and harness the power of large language models while ensuring that the responses that they're returning to users are relevant and personalized. And the way this is done is by supplying the large language models with data that the models were likely not trained on and probably were not trained on. And so in our case, we're supplying the OpenAI API with data pertaining to Duke's course catalog, registration processes, major requirements, graduation requirements, etc., so that the students that are utilizing the tool are able to receive relevant results. If you use a model right out of the box, it would provide very generic responses. And RAG is a very common technique used to alleviate this, to improve the accuracy and reliability of generative models. However, RAG alone is not always enough to achieve the desired results. And so we had to introduce some other techniques, which Adam will talk about next.
Thanks, Jack. So as he just said, RAG was not quite enough for our chatbot. The problem was we were just shoving information into the AI's face and didn't really know what to do with it. So responses became inconsistent, especially in terms of formatting, content, and conversationality. And so to fix that, we implemented this concept of fine-tuning. What fine-tuning is basically teaching an AI good responses from bad through example. So we gave the AI about 100 responses that it could base itself on. And then using the app in the top right that we built, we were able to grade the responses that it returned to specific prompts. And we graded the accuracy, the format, the hallucinations being avoided, and the conversationality of the bot, and then averaged those out. You can see the result of these averages for both the untuned and the fine-tuned model at the bottom. And as you can see, the untuned model performed significantly worse than the fine-tuned model. So we were very happy to see those results. And now I'll pass it over to Hui to talk about some of our components.
Thank you, Adam. So this is the overview of our system architecture. For the front end, we're using React and TypeScript. For the back end, we're using Python and Flask. The back end will be responsible for handling all the communications with the front end and also making calls to the OpenAI's API. For additional backend tasks, we're using Phi3, which is a small language model from Microsoft. We're storing all our data on MongoDB, and we're also using Redis as an additional caching layer so that data reading operations will be much quicker, and we believe that will vastly improve the user experience. And so if you could go to the next slide, I'm going to talk about our CI/CD pipeline. And so we containerize our applications with Docker and store all the Docker images on GitLab Container Registry. And to deploy our application onto a Kubernetes cluster, we use Helm so that we won't have to configure individual YAML files. At the moment, we have 2 running instances, one on Duke OKD and the other one on AKS. And so by the end of our presentation, you'll be able to try our app via a web link. And next up, Adam will talk about our program flow.
Thanks, Hui. So this is a very basic example of our workflow for our program. Of course, the app begins when you open the app and you're on the website. Then the user is in the front end and they're prompted to log in. Once they choose to log in, their login is sent to the back end and authenticated. And as long as the user is actually authenticated, they're able to progress through the front end to where they're able to input queries. Once they input a query, that query is sent to the back end, where our smaller language model parses it for a query type and gathers relevant information for it, and then passes that information to our larger language model. And that large language model uses that information to generate a response. And then once that response is generated, it's sent back to the front end where the user can see it. And then the user is able to input another query and repeat that process as many times as they want. And now Esther will talk about the changes from the beginning.
Thanks, Adam. So as you can see, where we started was a UI that definitely looked a bit more simple, and it didn't feel particularly unique to Duke. More importantly, the backend was largely disconnected, which meant that our Mongo database was not connected to the backend of our app, which also was not connected to the OpenAI API. And that meant that when a user input a query on the front end, that the backend had no response, and then obviously there was no response back to the user on the front end. This was a great launching point for our project because a lot of these connections were already primed to be made. We simply had to reconnect them and start working on implementing our own features. So where we are now is a more aesthetic UI. You can see we've incorporated Duke's colors and Duke's logo. We've also created our own little mascot for our web app. And we also have a conversational chatbot that does provide relevant information. So if I were to ask Atlas to recommend a class that talks about technology and art, Atlas recommended media, entertainment, and tech. And she gave a little explanation of why she gave that class recommendation. We also do have 2 theme options. We have a dark and a light mode. So if I were to toggle that button in the top left, I would be able to access a mode that may be a little easier on the eyes, especially if someone needs it for accessibility purposes or if they're using it at night. We've also implemented several new features, one of which is a user survey for personalization. This user survey asks things such as the user's major, what school they're enrolled in, what classes they have taken, their class year. And this allows Atlas to provide tailored information, especially for more general questions. So for example, if a user asked, what are the requirements for my major, Atlas would be able to respond accordingly. We've also implemented a quick view for each class as well as skill tags. This means that when you see in Atlas's response that there's a little button, you can click on that button and find all the information that would be available in Duke Hub without having to toggle between Duke Hub and Atlas. We've also implemented skill tags. So based off of past student feedback, each class has skills that each class teaches in. And lastly, we have successfully implemented authentication in Duke single sign-on, which we is going to talk about next.
Yeah, so to build up on Esther, having authentication is a key feature in a lot of enterprise software at the moment. In the case of Duke Atlas, each OpenAI's API call will induce a small fee, and so requiring users to log in will prevent the system from being abused, which in the long run will save the college a lot of money. Our system utilizes the backend for front-end authentication strategy, which means that the server will handle all the authentication logic instead of the client. We've also implemented a refresh token flow so that users wouldn't need to log in every time they want to use the app. And so hopefully, with our integration of Duke single sign-on, we'll make the app much more secure, but also not take away from the user experience. And Laura will continue.
So as we touched on, we've integrated a lot of security precautions. I'm just going to touch on a few of the ones that we've implemented on the front end. So in our project, we aim to create a sanitized user interface because we want Atlas to respond only to pertinent questions. So when Atlas is asked an irrelevant question, it will redirect the user to a more relevant one, as you can see in the image below. So one of the biggest challenges we faced over the course of this project was brainstorming how to collect student information without overstepping FERPA regulations in order to create a personalized user experience. So we wanted to have student information such as major, maybe career interests, or their school and other academic information, just so we had known like past classes and that sort of thing. But we didn't know exactly how to address this. So we met with the registrar and student information service director to brainstorm the best solution. And as Esther touched on briefly, we developed a completely voluntary survey, which includes a disclaimer informing users about their participation, as well as a skip all button for convenience. And as we also mentioned, we are securely storing all information in MongoDB, which is a safe database accessible only by security verified personnel. So all student data or potentially sensitive data is inaccessible to unauthorized users. And that just gives a brief overall summary of what we've been working on during our time here. So I'm going to hand it over to Jack to demonstrate a demo of Atlas and show you what we've been working on.
All right, so here we have a demo. You'll see that the first page that students will see is a login page. Because I'm already logged in with my DukeNet ID and password, in another tab, it will have already authenticated me, so I will not have to log in once more. However, if you are not logged in, then you will be asked to sign in with your Duke information. From there, if it is your first time accessing the app, you will be asked to complete the survey. As seen here, you'll be asked if you're an undergraduate or graduate student, as well as what school you're in, what majors, minors, and certificates you're taking, as well as the classes that you have taken. And then when students complete the survey, or like Esther and Laura have both mentioned, you can also choose to skip the survey at any point, and that information will not be saved. You will be directed to the main chat interface of Duke Atlas. You can see here that the student is wanting to learn about animation, and Atlas is able to respond with 3 classes that discuss animation, each of which have this nice quick view that shows the title of the course, as well as the description, meeting pattern, and professor. Additionally, if students wish to mention a class specifically, and they don't want a recommendation, they just want them to know information about a specific course, they can use our tagging system by typing the @ sign and then seeing class information that way as well. Additionally, like I mentioned earlier, Atlas has access to a lot of other resources and information about Duke. So here you can see that the student wants to know who they can talk to about advising, and Atlas is able to respond with a couple of resources that the student may find helpful, such as their college advisor and DAEs. Additionally, Atlas has a lot of information about majors and graduation requirements. So here you'll see that the student is asking about the courses left that they need to take for their major. And like Esther mentioned with the survey, because the student entered their major as well as the courses that they've taken, Atlas will be able to understand their computer science major who has taken the first 2 prerequisites for the major and respond accordingly with the relevant courses that that student still needs to take for their major. And finally, you'll see the dark and light mode that we have implemented. This is great for accessibility, like Esther said, as well as just if someone's personal preference is to use dark mode. And so that is the demo.
Yeah, so thanks, Jack. So for several stretch goals, as Adam mentioned earlier, we are partnered with NC Share. Part of that is the fact that we are all from different universities, but that also means that we are building this tool while keeping in mind that we would like to deploy this tool at other universities, at our respective universities, once it's deployed here at Duke. We would also like to convert to a graph database because we do recognize that a lot of Duke's programs and Duke's majors do not have the same structure, and some are more formulaic than others, which means that Atlas would have to be able to handle more complex prerequisite logic, and our vector embeddings are not able to capture that information right now. So using a graph database would allow us to not only be able to see prerequisite relationships, but also other related course relationships. And we would also like to create clickable skill tags. As you saw in the demo, there are those skill tags available. And we want to make sure that those are clickable so that users can find other relevant classes. And that would just make the user experience more smooth. And lastly, this still is a proof of concept, and which means that we obviously are always looking for more course data. We currently only have spring 2024 class data. And so this app is not as viable is not ready for deployment yet because we don't have the upcoming semester's data. And finally, Allura is just going to share some final words.
So just wanted to thank you all so much for your time, and thank you so much to the Code Plus team, especially Jen and Isabel, who we couldn't have done this without. And to our team leads, Drew and George, you were so awesome, and we were so lucky and happy to work with you. We're so excited by what we were able to create during this program, and we'd love for you all to try it out. So please check it out using the link below. Yeah, we'll send the link in the chat, and we'd love to take any questions you might have. Thank you.